Welcome to another edition of Math for Novice. In this edition, we will be looking at this problem which states that suppose we have a sequence whose the first term a1 is 1, the second term a2 is 2 and an plus 2 is equal to twice an plus 1 minus an plus 2. Then we have to find the value of an for every n. Equations such as this involving terms of sequence are referred to as difference equations. This particular difference equation, which we can write as an plus 2 minus 2an plus 1 plus an is equal to 2, is a second order linear difference equation with constant coefficients. So this is an example of a second order linear difference equation with constant coefficients. Now, if the right hand side of such a second order linear difference equation with constant coefficients is equal to 0, then we call it a homogeneous equation. So a homogeneous equation is, for this particular case, is an plus 2 minus 2an plus 1 plus an is equal to 0. Now there has been a lot of work which has been done on such equations, and we know some very interesting facts. And since the right hand side is equal to 2, so such equations will be called non-homogeneous second order linear difference equation with constant coefficients. So basically we can think of writing an as a sum of two quantities. One is Gn and the other we will call Pn. And what is Gn? Gn is a solution of the homogeneous equation, which is this one, and Pn is one particular solution of the non-homogeneous equation. So any solution an would be of this type Gn plus Pn, and these first two values that are given a1 and a2 will specify the solution for us, and therefore these are often referred to as boundary conditions or initial conditions in this case, which will actually help us in specifying exactly what this sequence an would look like. So we will first solve the homogeneous equation, obtain Gn, then we will get a solution Pn, and then we will be able to get the final solution. So that's the plan. Now to solve the homogeneous equation, we will take help of the characteristic equation t square minus 2t plus 1. Now how is this obtained? So corresponding to the term a, we have 1. Corresponding to the term 2n plus 1, we have 2t. And corresponding to the term an plus 2, we get t square. Let us now consider a homogeneous equation which is of this kind: xn plus 2 plus a xn plus 1 plus bxn is equal to 0. And this has the characteristic equation t square plus at plus b is equal to 0. Now this is a quadratic equation, and we know that there can be three situations. So there can be two distinct real roots, and this will happen if a square is greater than 4b. And in this case, let r1 and r2 be the two roots. Then the general solution of this equation is xn is equal to a r1 to the power n plus b r2 to the power n. Now the second case that can happen is that we have repeated roots, and this will happen when a square is equal to 4b, and in this case, say r is the repeated root, and then xn is of the form a plus bn into r to the power n. For this particular problem, we are in this situation with repeated root. Our solution is of this form: a plus bn r to the power n. R in our case is 1. And the third case happens when you have complex roots, and this happens if our s square is less than 4b, and suppose the complex roots are some r e to the power I theta and r e to the power minus I theta, written in the Euler's form. In this case, the solutions are a cos theta n plus b sin theta n. Let us now consider the non-homogeneous equation. xn plus 2 plus axn plus 1 plus bxn is equal to c. Now, to find one particular solution, we have to consider several cases. Case 1 is 1 plus a plus b not equal to 0. In that case, xn is equal to c divided by 1 plus a plus b is a solution. It is very easy to check this just by substituting this and doing that. When 1 plus a plus b is equal to 0 and a is not equal to minus 2, then xn is equal to cn divided by a plus 2 is a solution for this non-homogeneous equation. And finally, when 1 plus a plus b equal to 0 and a is equal to minus 2, then xn is equal to cn square by 2 is a particular solution. It is very easy to check this just by substituting this on the left hand side and doing the algebra. Now, once we have the particular solution, we have to now determine that which case is this. Now, to determine which case we are in, let us write this equation here. So, I have an plus 2 minus 2an plus 1 plus an is equal to 2. So, matching this, what we get is that a is equal to minus 2, b is equal to 1 and c is equal to 2. So, a is equal to minus 2 and is 1 plus minus 2 plus 1, which is equal to 0. So, we are in case 3, and hence one particular solution that we will be working with is xn is equal to n square. So, xn is equal to n square is a particular solution of this given equation. Now, we look at the general solution of an plus 2 minus twice an plus 1 plus an is equal to 2, subject to the conditions that a1 is equal to 1 and a2 is equal to. So, we have already seen that the general solution of the homogeneous equation is c plus dn, and that a particular solution of the non-homogeneous equation is n square. So, therefore, the general solution of this non-homogeneous equation is c plus dn plus n square. Now, a1 is c plus d plus 1 is equal to 1. So, this gives us c plus d equal to 0 or c is equal to minus. Another a2 is, putting 2 there, is c plus 2d plus 2 square, which is 4, and that is given to be 2. That gives us c plus 2d is equal to minus 2, and putting c is equal to minus d as we have got here gives us minus d plus 2d is equal to minus 2, or d is equal to minus 2, and therefore c is equal to 2. General solution with the condition that a1 is equal to 1 and a2 is equal to 2 becomes an is equal to 2 minus 2n plus n square. Now, straightforward algebra gives us that this is 1 plus n minus 1. So, the general form of an 1 plus n minus 1 whole square. And when you put n is equal to 1, you get 1. When you get n is equal to 2, you see that you get 2 for the boundary conditions. In this case, the initial conditions This is a good point to start.